Hello everyone. In this video, what I'd like to do is to talk a little bit about the lungs and what happens at rest. So before you take that deep breath in future videos we'll talk about inhalation and exhalation, but here I'd like to just give you an overview of the lungs and its components and the different pressures that you may encounter. So first of all, I'd like to discuss where the lungs are found. The lungs are found within the thoracic cavity, and later we'll have a separate video on the cavity, what borders it, and things like that. But here, I'd like to just briefly start by stating the functions of the lungs. So the lungs have various, or the thoracic cavity. So I'd like to start by giving you the functions of the thoracic cavity. So the thoracic cavity is a place where various muscles that connect to the upper limb attach to. So you have these muscles that are going to attach to the upper limb and scapula. So they're going to function to move your upper extremity. So they're going to attach at the spine, at the thoracic spine area. So that's one of the functions of the thoracic cavity. It serves as the attachment point for these muscles. The next important aspect of the thoracic cavity is that it's also the attachment for the mammary glands. So if you can see here, it also serves as the attachment point for the mammary glands. And we have our intercostal muscles, as you can see here. We have our mammary lobes, and then we also have other components like fat and the mammary ducts. So this is the structure of the mammary glands. As you can see, the chest wall, which is part of the thoracic cavity, is an important component, plays an important role for the attachment of the mammary glands. So it's an important component for the attachment of various muscles that move the limbs, specifically the upper limb. It's also important for the attachment point of mammary glands. And of course, its huge function is to protect everything is inside, specifically the heart, the lungs, the great vessels. And we'll talk more about the mediastinum and the components that are inside of the thoracic cavity in the future video. The thoracic cavity contains the lungs. So in this video, I'd like to discuss more about the structure of the lungs. So the lungs have this component in green, which is known as the visceral pleura. So these are the lungs, as you can see here, and these structures in green, these are the lungs, okay? And air is gonna come right here through the trachea to the bronchi and get inside of the lungs. Now, the lungs contain a covering around them, and there's going to be a structure right over the lungs, and this is known as the visceral pleura. So let me actually write this down here for you guys so you can see. This is known as the, let's make this in orange. Visceral pleura. Now the lungs also have other components as well. So the lungs also have a covering that's around and actually attached more so to the ribcage itself. This is known as the parietal pleura right here. Parietal pleura. And then the lungs also have this space in between. They also have this space here in between the visceral pleura and the parietal pleura. So if we draw this right here, this space right here is known as the pleural space. And this space is important because it has, inside of it, it has fluid. And this fluid is going to prevent the visceral pleura and the parietal pleura from rubbing against each other, preventing things like inflammation, for example, and pleurisy, which is like what occurs when there's a lot of friction when you rub these surfaces against each other. So this space here between them has a lot of fluid. Having said that, there are also lymphatics that are actually present that are going to work to drain this fluid, to prevent an overaccumulation of fluid. So this is lymph from the mediastinal trunk. There's going to be these branches which are going to take away fluid to prevent an accumulation in the pleural space. Now this visceral pleura and the parietal pleura have the fluid, but they're actually connected to each other. So it's actually a potential space if you want to think about it this way. Now what I want to do is I want to discuss some of the pressures that are found in the lungs. So let's say right here inside of the alveoli, right, because these are eventually going to give rise to the alveoli. Right here, you're going to have a certain pressure. And this is known as the PPOL, or the pulmonary pressure. Inside of the pleural space, you're going to have a different pressure, right? You're going to have an intrapleural pressure, or PIP, right? And then around it, right, just in the atmosphere, we have atmospheric pressure right here, or also known as the barometric pressure. I could have also written it right here, right? That's the pressure that's going to go into your lungs when you breathe in and out when you breathe out. So again, this is the lungs. We have our pulmonary pressure, intrapleural pressure, and atmospheric or barometric pressure. You have the visceral pleura clinging to the actual lungs parenchyma, to the lung surface. You have the pleural space, and then you have the parietal pleura, which is attached to the chest wall. And you can see these are the ribs and the intercostal muscles, which are between the ribs. And we'll talk about those later. This forms the chest wall, right? The ribs and the muscles between the ribs. And these muscles are very important for respiration. We'll talk about those when we talk about breathing in and breathing out. So these muscles are called intercostal muscles because they're in between the ribs. And then I mentioned that the pleural space has fluid, which is going to prevent pleurisy and prevent the visceral and parietal pleura from rubbing against each other. And then you have lymphatics to drain and prevent excessive fluid accumulation, which can change pressures and things. So you want to remove too much. If there's too much fluid, you want to remove it because this fluid can actually push on the lungs and cause it to collapse. So you want to prevent that. Now, another important thing to understand is we can also discuss the pressures across components. We can also discuss the pressures across the lungs and the pleural space. So this here is actually known, this component here, let's call this A, and let's make this B. So A is referred to transpulmonary pressure. And then the pressure across this in B is known as the transthoracic pressure. So it's known as the transthoracic pressure. Okay? So now, let's also discuss another important component, that this intrapleural pressure is negative. So let me give you the actual numbers right now. So normally the pulmonary pressure is approximately the same as the atmospheric pressure. So it's approximately 760 millimeters of mercury. Now the intrapleural pressure is actually negative. It's actually negative relative to atmospheric pressure. It's actually around -4 or 4 less than the atmospheric. So we can also say, by the way, atmospheric pressure at sea level is 760, which is the same as the pulmonary pressure at rest. But the intrapleural pressure is 4 units less. So we can say the pulmonary pressure is actually 0, and this will be -4, or we can say 756. Okay? And atmospheric pressure, we can also say, we can call it as 0 as well, because we're looking at the relative pressure, right? And also, because of gravity, the pressure is not equal across these components. Gravity pulls the lung down. So because gravity pulls the lung down, the visceral pleural is going to be more connected to the parietal pleura here at the bottom. So there's going to be less of a space. There's going to be a lower volume here, right? Because gravity is going to push the lung down. So the space here is going to decrease. And there is a nice relationship called Boyle's law, which states that P1V1 equals P2V2. So as I decrease the volume, the pressure goes up. They're inversely proportional. So the pressure at the bottom is slightly higher than the pressure at the top. At the top, the lung goes down, the volume goes up here, and the pressure goes down. So because of gravity, the pressure, the intrapleural pressure is slightly greater at the bottom than at the top. So let's say at the bottom, it can be like negative. It's slightly greater than at the top. At the top, the pressure is less. So maybe here's -2 or -3, and there's like -7, for example. But on average, it's -4. But because of gravity, there are variations in pressure as you go from the apex to the base and vice versa. The intrapleural pressure can change. So I wanted to point that out. Okay, so we had the transpulmonary pressure is equal to the intrapulmonary pressure minus the intrapleural pressure. And if you do the math, that would be 0 minus -4. 0 minus -4. So that's actually equal to +4. And the transthoracic pressure is the pressure between the intrapleural space and the atmosphere. So that's actually equal to, and you can easily calculate it, it's -4 minus 0, which is -4, equal to the intrapleural pressure at rest. Okay? And if we wanted to, we can also specify the pressure between the actual lungs and the atmosphere. We can go all the way like this. Let's call that C. And C would be the transrespiratory pressure. And you can actually calculate that as well. The transrespiratory pressure is just going to be the intrapulmonary pressure minus the atmospheric pressure, which is in this case is 0 minus 0 equals 0 at rest. So these are the pressures that you can be asked about. And at rest, the transpulmonary pressure is +4, the transthoracic is -4, and the transrespiratory is 0. And as you can see, as we'll see later, when we breathe in and out, the pressures will change. So at rest, there is no difference between atmospheric pressure and the intrapulmonary pressure or the intraalveolar pressure inside the lungs. That's why there's no air moving in. Air only moves due to a pressure gradient. So when we breathe in and out, we're going to change things, and we're going to allow the movement of air in, specifically oxygen, and then CO2 out. Okay? And then one more thing I wanted to discuss is how do we maintain this negative intrapleural pressure at -4? How can we keep this intrapleural pressure? How can we make it negative? And there's a few ways that we can actually do that. So let me actually get a marker here. Let me change the color. Let's make this blue. And so there's various ways. First of all, the lungs themselves are elastic. The lungs themselves, oh, let's make this blue. The lungs themselves are elastic. So the elasticity of the lungs. Now, why is this important? Because the lungs actually want to collapse. Let's call this I, right? Instead of 1. So the lungs naturally want to go in this way. They want to collapse. And what this is going to do, this is going to pull the lungs inward. So that's going to increase the space in the pleural space. It's going to increase the volume in the pleural space. And we know if volume goes up by Boyle's law, as you can see here, pressure goes down. So that's one way it helps maintain this negative pressure below atmospheric pressure. The second one is something called surface tension. And this has to do with the air-water interface, which we'll talk about in another video. But again, this is trying to collapse the lungs. It has this inward force. And therefore, again, it's trying to reduce the pressure, increase the volume and decrease the intrapleural pressure. And the last thing which is going to happen here, there's also going to be elasticity of the chest wall. Elasticity of chest wall. So just like we had the elasticity of the lung, now the last one, let's actually do it in a different color. So you guys can see it better, because the first two were collapsing forces. This last one is actually a force that's going to cause the parietal pleura to expand. So this is the elasticity of the chest wall. Okay? And this is going to cause, and this is allows the chest wall to expand this direction, outwards. And because of that, again, you're moving the parietal pleura this time away from the visceral pleura. And that's again going to increase the volume and decrease the pressure. So these three things are actually maintaining a negative intrapleural pressure. They're all increasing the volume here in the thoracic space, in the intrapleural space, but they do it differently. 1 and 2 here are by collapsing the lungs, and the elasticity of the chest wall by expanding the chest wall, pushing that parietal pleura away from the visceral pleura. So there you have it. That's how you keep this pressure negative at 756 at rest. And this is really, really important, because this negative pressure is what allows the lungs to be held open, to prevent collapsing of the lung. We don't want to collapse the lung, right? So that keeps the lung open. And when we breathe in, this intrapleural pressure is going to get even more negative. And that's going to allow the lungs to expand out further, and so you can actually breathe in. And then when you breathe out, this space is actually going to become less negative, as you will see in the future videos. And of course, the pulmonary pressure is going to change relative to the atmospheric pressure. There's going to be a pressure gradient that's going to allow air to move in and out. And we'll see that in the next video. So I really hope you found that helpful. In the next video, I'll talk about the process of inhalation. And then in the subsequent video, I'll talk about exhalation. I hope you guys enjoyed this video, and I'll see you in the next one. Thank you.